Okay, good evening children. Today we are discussing chemical property of amines. First is acylation. So what is acylation? So this is an amine with acetyl chloride. Then what happens is that in short this Cl and one of this H gets involved in their loss, and the product form is CH3, CH2, then there is NH. This N gets connected with this C double bond O, CH3. So this plus HCl. And we should take here a base which is more basic than amine. Say pyridine. Pyridine, Pyridine. Pyridine is an organic base, more basic than amine. So what this pyridine will do? Pyridine will help in the removal of HCl. Pyridine will help in the removal of HCl, and this reaction will go more in the forward direction, and we will get more of this product, more of this acylated product. So this is called acylation because acyl group has come. That's why it is called acylation reaction. Now, how this actually happens? A little bit of small mechanism involved. Is CH3, CH2, N, H, lone pair, and then C, double bond O, CH3, Cl. So what actually happens is first this nucleophile, this lone pair attacks here. This pi bond breaks and comes over oxygen. And oxygen has two lone pairs. This is what happened first, and then this thing happens. CH3, CH2, N, H. The bond is formed. C, O. And now three lone pairs. So it will be minus Cl, CH3, and this N will become plus. So this is first that is formed, and now what happens is this lone pair comes back, and because of that this Cl minus will come out. And with that this N is highly electronegative, N plus is more electronegative. So this bond electron will also come towards nitrogen, and this H will come out as H plus. So this H coming out as H plus, this Cl coming out as Cl minus. So they together will form what is HCl, and we get the product, acylated product. So this is acylation. Acylation can also be done with acetic anhydride. I am giving you one example of that. Suppose now we have aniline. 1 degree amine, and acetic anhydride is CH3, C double bond O, C double bond O, CH3. So this is acetic anhydride, and we are using organic base pyridine. So as before, what will happen is this group will come here. One H will come out, and in its place this group will get inside. So the product will be NH, then this N will be connected to this C, C double bond O, then CH3 plus, and this side product will be CH3 C double bond OH, CH3 COOH. So this is an acid. This pyridine will help in the removal of this acid, and the reaction will go more in the forward direction. Now, what is the name of this product? In acylation reaction, you see, this is we know that this group, this is a functional group. It is called amide. It is called amide. So you can see here, acylation product, we get amide. We get amide, not actually amide. It is substituted amide. This is substituted amide, and now I am naming this compound. How it is named? How this is named? Before that, let me tell you how this compound is. CH3 C double bond O NH2. This is amide, 2 carbon atom, so its name will be ethanamide. The name of this group compound is ethanamide. And suppose we have now, say, this compound. So this is also an amide, this substituted amide. So the name of this compound will be, now here there is a methyl group. There is a methyl group. So its name will be N-methyl ethanamide. So in this way, amides or substituted amides are named. So now we can easily name this compound. Here the name of this compound will be, now amide is from here, CH3 C double bond NH2. So one H is replaced by this group. This is ethyl group. So its name will be, the name of this compound will be N-ethyl, 2 carbon atom chain, ethanamide. N-ethyl ethanamide. And similarly, the name of this compound will be this is from here is going CH3 C double bond NH2. So here it is phenyl group. So it will be N-phenyl ethanamide. N-phenyl ethanamide. And the common name of this compound, this common name you have to remember, it is acetanilide. This compound, common name, it is acetanilide. Okay, now another name very similar to acylation, it is benzoylation. Benzylation. So what is benzylation? I am writing an equation for benzylation. Aniline plus, say, benzoyl chloride, C6H5 C double bond OCl. With benzoyl chloride So just like that, before this group will come, one H will go out, and then this is called, since benzoyl group is coming, so then it is called benzylation. Here acyl group was coming, so acylation. So acylation, benzylation, similar. So this is one chemical property. Now next chemical property that we are discussing is your carbylamine reaction. Next very important reaction is carbylamine reaction. Aliphatic primary amine or a aromatic primary amine with KOH and chloroform. It produces a poisonous, foul-smelling substance which is isocyanide, and these are some byproducts. This reaction is given by only 1 degree amine, and this we can that's why make use of in order to test 1 degree amine, whether it's aliphatic or aromatic. One information is there was a major disaster that took place in the year 1984 in Bhopal, capital city of Madhya Pradesh. There in Union Carbide gas factory, there was a leakage. There was a leakage of methyl isocyanate. There was a leakage of this gas from a factory, Union Carbide factory, and because of that leakage, many persons had lost their lives. Many people are still surviving with lot of deformity in the body. Many has lost their eyesight and so on. So that was because of methyl isocyanate gas. Okay, now coming to the next reaction, that is reaction with nitrous acid. Now nitrous acid is a very unstable. We cannot use this as reagent from the reagent bottle in the chemistry lab. This has to be prepared inside the test tube, by using NaNO2 and HCl. NaNO2 HCl will produce ethanoate. So what happens is, first aliphatic primary amine. We are using aliphatic primary amine with nitrous acid at a very less temperature, that is 0 to 5 degrees Celsius. This temperature is maintained by using ice. We have to use ice for this, and there is a formation of alcohol. With brisk effervescence of nitrogen gas, and another byproduct will be water. So this is the reaction with nitrous acid. Now with aromatic primary amine, the reaction is slightly different. With aromatic primary amine, there is a formation of diazonium salt. The formation of diazonium salt. There is the formation of diazonium salt and water. So why there is a difference, let me tell you here one thing, is that actually like this compound is formed here also, like this compound is formed, like here in this case we get R alkyl diazonium salt, we get alkyl diazonium salt, like if this X is this Cl, and then what happens is that this compound it breaks down. It breaks down in presence of water. In presence of water, this breaks down to form R OH plus N2 plus HX. So here also, so basically these two reactions are same. Here this is aromatic diazonium salt formed. Here it is here also it is formed aliphatic diazonium salt, but this being unstable, it breaks down. It breaks down to form alcohol, nitrogen, and your HX. Actually, it's not water. Actually, it should be like because of this amine, your HX. Here also should be. So this is a very important reaction. This reaction with nitrous acid. So if we make a summary here, we can say that aliphatic primary amine with nitrous acid, we are not using actually nitrous acid. We are using NaNO2 HCl at 0 to 5 degrees Celsius. Then we get alcohol, brisk effervescence of nitrogen gas, and the halogen acid. Actually, this aliphatic diazonium salt is formed in this reaction. Since it is unstable, it breaks down into alcohol, nitrogen, and halogen acid. Whereas in case of aromatic primary amine, same reagent nitrous acid at this 0 to 5 degrees Celsius temperature, there is aromatic diazonium salt formed. Aromatic diazonium salt. Here also we can write here halide ion, and this being more stable than this one, it doesn't break down. So this is the reaction with nitrous acid. Next we are doing is reaction with Ginsberg's reagent, which is benzene sulfonyl chloride. Okay, next we are discussing is reaction with Ginsberg's reagent. Ginsberg's reagent is this compound, benzene sulfonyl chloride, C6H5SO2Cl. So here we have a 1 degree amine with Ginsberg's reagent or sulfonyl chloride. You know, like acylation type of thing happens. This H and this Cl combines to form HCl and gets removed, and these two gets connected in this way, R and H, then S double bond O, benzene ring. This is called a sulfonamide, and this is formed as a precipitate. This is formed as a white precipitate. Now here you see, since this nitrogen is highly electronegative, so here we have a acidic hydrogen. Acidic hydrogen we have, and since we have acidic hydrogen, this precipitate will be soluble in alkali. So if we add alkali into the precipitate, this precipitate will dissolve. So this is what happens with 1 degree amine. Now if we take a 2 degree amine, this is a 2 degree amine with Ginsberg's reagent and again we get a precipitate here. But you see, unlike in this case, here we don't have acidic hydrogen. Since we do not have acidic hydrogen here, this precipitate will be insoluble in alkali. So you see, there is a difference in the behavior of 1 degree and 2 degree amine, and that's why this reaction we can make use of to distinguish between 1 degree, 2 degree and 3 degree amine. This is called Ginsberg's test. In case of 1 degree amine, the white precipitate that is formed is soluble in alkali. In case of 2 degree amine, the white precipitate that is formed is insoluble in alkali. And now what happens in case of 3 degree amine? In case of 3 degree amine, R, N, R. In case of 3 degree amine, since there is no hydrogen attached, so their precipitate formation will not take place. So we have different observation with different degree amines. So this can be used to distinguish between 1 degree, 2 degree and 3 degree amines. Okay, next is reaction with bromine water. So reaction of aniline, this will be number 6, aniline with bromine water. So let me write the equation here. This aniline plus Br2 bromine water. You know the color of this bromine water is red in color, and what we get is this product. There occurs tri-substitution. There is Br coming at ortho, this also coming at para, also coming at another ortho. And this is a white precipitate that is formed. A white precipitate is formed, and of course side product will be HBr. So this is bromination electrophilic substitution reaction. You know, in this the electrophile is Br plus bromonium ion. Now question arises, why is this, why there occurs tri-substitution? The reason why there occurs tri-substitution is we can find out that in aniline this ring is highly activated. This ring is highly activated, and because of highly activated benzene ring, there occurs tri-substitution. If we draw the resonating structure, then we can understand that it is highly activated. So let us draw the resonating structure of aniline. So this lone pair will come over here, and this pi bond will break and it will come over this place. So here 2 electrons come, that's going to be negatively charged. This nitrogen atom will be positively charged. So you see there is a flow of electron into the ring, and the ring is getting activated. After that, this lone pair will come here, this one will bond here, and this one pi electron will come over here. and this one then will come here. So you see, from all these electrolytic structures we can understand that in aniline the benzene ring is highly activated, and this is the cause of tri substitution taking place. And what will be the observation here is that this red color will be discharged. Now one question can come here is, suppose if you are asked to distinguish between aniline and this compound, aniline and benzyl amine, distinguish between aniline and benzyl amine. So this can be distinguished by bromine water test. These two compounds can be distinguished by bromine water test. Like here, because of this CH2, resonance will not take place. The ring is not activated here. So like this reaction will not happen with benzyl amine. So aniline with bromine water will give a white precipitate, and this reddish brown color of bromine water will be discharged, and like this thing doesn't happen in case of benzyl amine. So children, there are some other chemical properties that we will be doing in the next class. Till then, good night.